Perhaps the most mysterious aspect of the universe is that we understand so much about it. The basic rules of the game all fit on a piece of paper if you write neatly and concisely. In the first 6 seconds of the universe's rapid expansion, it had already cooled down to 10 billion degrees Kelvin, protons and neutrons had formed, and neutrinos had already decoupled from this thermal bath. By the end of the first 3 minutes and 42 seconds, the nuclei of the lightest elements, hydrogen, helium, and lithium, had all formed. This is a remarkable triumph, synthesizing quantum physics with Einstein's theory of gravity, applied to the universe as a whole. But what happened at earlier times? Running the arrow of time in reverse, before the first 10 to the minus 43 seconds, we don't really know. Everything was so small that macroscopic notions of space and time ceased to make sense. What we do seem to understand is that it will require significantly new elements involving a quantum theory of gravity, unifying the physics of the very small with the very big. Figuring out how all the pieces of the puzzle fit together remains one of the deepest and exciting mysteries of the universe.